This is 3.4, and it talks about something called the composite function. It says, in the real world, functions frequently occur in which some quantity depends upon a variable that in turn depends upon another variable. For instance, the number of employees hired by a firm may depend upon the firm's profits, which may in turn depend upon the number of items the firm produces. Functions like this are called composite functions. It's a function of a function. And you know what? You've seen composite functions. You have. The problems we just worked, if I were to look at it as a function, like this guy right here, 3 to the 2x plus 1, that's a composite function. 3 to the x is a function. 2x plus 1 is a function. And I put them together. So 3 to the 2x plus 1 is a function with a function. It's kind of like I've been known to collect bears. And I have a bear that has a bear. So I have a teddy bear that has its own teddy bear. And I have one that's even multiple. I have a mama bear which is holding a baby bear which is holding a teddy bear. So I have a bear that has a bear that has a bear. Well, what is it? It's essentially, it's comprised of essentially similar things. So it's a function of a function. So that's what a composite function is. So you've seen them, you just don't realize you've seen them. Oh, another one you've seen is composite function. The outside function is square root, and the inside is 2x minus 1. Put them together, you have the square root of 2x minus 1. It's a composite function. You've seen them. They're functions that have functions. So essentially, what is a composite function? Well, notation is f with a little circle g of x, which is f of g of x. So notice, instead of having an x here by itself, it's got a function. So it's a function of a function. We most of the time call this fog, F-O-G, fog. He has a brother, which is this guy, which is g of f of x. We normally call him Goff. So we have fog and Goff. So in order to create a composite function, in fact, in the engineering calculus, there is a whole chapter devoted to making new functions from old. It says you take old functions, put them together, and come up with something new. It's like taking a chocolate cake and a mix and a or batter and a vanilla batter and mixing it together, and they call it marble cake. So it's a combination of both. And it said if f of x is equal to 3x and g of x is equal to 1 minus x squared, find fog of 5 and Goff of 5, fog of x and Goff of x. So essentially what would you do? If I were looking, and I'm going to leave this guy down here pretty much alone, if I look at fog of 5, that says in the function f, you're going to stack g of 5. Now g of 5 is a numerical value. Remember, put in x, get out y, put in x, get out y, put in x, get out y. So I do a calculation, what's g of 5? Well, g is 1 minus x squared. So g of 5 is 1 minus, or plus, 5 squared. It's 26. So that says I really want to find f of 26 because g of 5 is 26. What's f of 26? Well, f of x is 3x, so this would be 3 times 26, and then 3 times 26 is 8, 18, 6 and 1, 7. It's 78. It says I performed g first, came up with a number, and then stuffed that number in. So why? Because it is made up of two different separate entities. Now, if I wanted to then go into essentially Goff of 5, that is g of f of 5. What's closest to the 5 is what you put in first. So then I need to calculate f of 5. Well, what's f of 5? F of 5 is, f is 3 times x. 3 times 5, which is 15. So this is g of 15. What's g of 15? 1 plus 15 squared. And now I don't know what 1 plus, oh, they've already calculated it out for me. I just have to look, is 226. You just got to keep your eye on the prize. Keep your eye on the prize. Now they say, now find Goff of x, or fog of x. That says in the function f, you're going to stuff the function g. Now I liken this to Thanksgiving, right? We got this big old turkey. Maybe you had turkey for Easter. I don't know. I think my mother used to cook lamb. So any time she cooked lamb, was it Easter? But you have this big old turkey. And inside the turkey, what do you normally put? Stuffing. So sometimes you're the turkey, sometimes you're the stuffing, right? So if you are the stuffee, that thing is being stuffed in, right? You're the inside function. You're going to be on the inside, and the turkey is on the outside. So that when I look at the idea of fog, f of g of x, g is the stuffing, f is the turkey. So what's closest to the x is the stuffing, what's furthest is the turkey. And when I look at Goff, who's closest? F. He is the stuffing, and now g is the turkey. So that if I look at f of g of x, that's fog, that says in the function f, you're going to replace all of the x's by g. So in f, you're going to pull the x out and then replace it by g. And so this then becomes 3 plus 3x squared. New functions from old. Now with Goff, now you're going to pull the x out. Now you're in g, you're stuffing it with x. F of x is 3x. See, if you can do f of 5, you can do f of 3x. It's the same concept. That says in g, pull out all of the x's, and replace it by g. And this becomes 1 plus 9x squared. It's a pure replacement.